Hello everyone, welcome to AI Anytime channel. In this video, we are going to train a very simple and small language model on our data set. So we'll take a data set from Hugging Face. It is related to healthcare. It's about disease symptoms, and we'll leverage GPT-2, which is an open source language model. I'll not say it's not a large language model. It's a very simple language model that we're going to leverage and on our data set, and we'll try to have a new model, okay, in the end of this video that will basically execute the task that we want to achieve. So for example, if you have disease symptoms, I give the name of the disease and it should generate me the relevant tags which is associated with that disease. So for example, if I write kidney failure, so it should tell me that you have urination problem or you have obesity and so on and so forth, right? So those kind of the task. Now in 2024 we're going to look at the rise in small language model, because people have started talking about smaller language models, and the Microsoft has released five series of language models, and there are the Orca and a lot of other models which have been called as smaller language models. And now we have been living in a hype of generative AI, so whatever happens in the community, people have started talking about it. So we'll try to see that how we can do something small, and this is a beginner friendly video. If you already know that how to leverage GPT-2 to create a new model which will generate some tokens, please don't watch this video, you'll be wasting your time. So if you don't know how this works and how you can leverage these models on your data sets to create a model less than, for example, 500 MB of size to perform a specific task. So how can we do that? And that's the agenda of this video. So let's jump in and start building this. So if you look at here, I am on Hugging Face repository of models, and I am right now on digital GPT-2. Okay, so GPT-2 again created by OpenAI when it was not again, it's again a non-profit, but that time they were completely looking at the open source thing, and that's where they created GPT-2. And now you can see it says sought for distilled GPT-2 is an English language model pre-trained with the supervision of the smallest version of generative pre-trained transformer. Okay, GPT-2. Like GPT-2, digital GPT-2 can be used to generate text, and that's what we want. We like to see if it can learn the patterns from our data, or it can learn that how to generate text. That's the agenda of this video. Now, and I will tell you that what kind of use cases you can probably work with, and I feel that's a good way of doing it, because once I was working on this video, I realized that I'm going to use this in some of my use cases. I will tell you in the later part of the video. Now it's developed by Hugging Face, and that's why I'm going to use this model. Uh, and a transformer Apache 2.0, you can use it in for making money as well. It's commercially available. You can see English language model pre-trained, blah blah blah. 124 million parameter. So only 124 million parameter version of GPT-2. Okay, and that's what we're gonna do. Uh, which has, oh, by the way, digital GPT-2 which has 82 million parameters were developed using knowledge distillation, were designed to be faster, and you can find out the details here. Now you can see a lot of spaces over here, but I'll show you that we're gonna build a cool thing here. I am very optimistic about it, and I know you will love that. And you can see here I am going to write the code, which is on Colab, simple GPU T4. Now if you come over here, this is the data set I'm going to use. It's by QN and D or somebody, the creator. The credit goes to him. It's not my data set. It's by somebody. I like the data set. I like the idea, and that's why I'm creating this video. But the credit goes to him. He is the creator of this video, guys. So please, star or star this repo or something like that. Okay. Now I'll show you. We have to do a bit of pre-processing on this data set. We'll do that. We'll go a bit of traditional machine learning way in this video. Uh, you have to understand, language model is like fascinating, right? I mean, not language model, the large language models of the world. Okay, language model is not new. Okay, we have been seeing models which generate tokens. We have been seeing this for like years now. Okay, the Marco chain and a lot of other models or the algorithms or the simulation techniques where people used to generate tokens. Now a simplest language model can be an n-gram model. Okay, and then n can be anything, 1 2 3 whatever. Okay, now bigram, unigram, or whatever models. Now if you consider an n-gram model, the next tokens prediction in that sequence is going to be conditioned as n minus 1, so previous. Now for example, I like to, now this is a simple sentence that can be anything, right? Once you have a training data, I like to eat, I like to draw. So that draw, eat, etc. will depend on the previous token if you are using an, bigram or unigram models or any other models. Like, so it depends on the previous tokens where the formula is n minus 1, by the way. Now depends what is your n. So it's simple. The simplest language model can be an unique bigram model, for example. So don't always see that only Llama 2 or GPT-4 is the language models that people have been using it. But that's a part, right? Let's write some code here. So what I'm going to do first is going to install few libraries that will help us perform this. Now, of course, we need Torch, which comes by default in Colab nowadays. I'm going to have Torch. By the way, they also have transformers now installed by default. But I'm going to install this because I'm not sure if you are using Colab or any other GPU rentals, or if you are doing it locally. So let's do that. So I'm going to have sentence piece, which is a dependency of transformer. Sentence piece, which helps you with the tokens. Sentence piece, pandas. I need TQDM. Last time I did a mistake. One of my subscriber told me that I was not able to uh, correct it correctly when I was writing TQDM, but I hopefully this time I wrote it correctly. Data sets. Okay, now these are the things that we need for the installation. Now, once we install that, what I'm going to do is have data sets first thing first, because we're going to need the data sets from Hugging Face. So from data sets, import load data set, which is correct. I don't need glue, etc. for now. Okay, load data sets, and then dataset dict, dictionary of dataset. Okay, you can see here dataset dict, and then I need dataset itself. Okay, so this is from datasets. Now, next thing is import pandas as PD, and then let's get very quickly here. Import HD, import datasets, and from TQDM for the progress, etc. import TQDM and import time. This should do. Now, once I get this, the first thing that I'm going to have here is the load data thing. So let's load the data. So how do we load data? Let's call it data sample, and data sample equals, I'm going to use the load data set here. And for that, we need this, we need to copy this. So let's copy it here. And once we copy, I'm going to paste here. Okay, now this is the way you can load any data set. If you have a data locally, you can also do that. You can also define, if you have a CSV file, you can also load that from local. Maybe I can give the command in the description box. Okay, if you don't find anything, just go to Hugging Face documentation, you will get it. Data sample. Now let's see what are the information we are getting here. Data sample. You can see it's a dataset dictionary. Features, we have 4 columns, for example, code, name, symptoms, treatments, and the number of rows 400, which is too less. And that's why I once we train it for more epochs, or even generally, like it will start overfitting, because you have really small data here. 400, I will say nothing, because once you train it, 80% will go to training, 20% will go, so 80 rows will again go to validation, of course. So you have around 320 of training, which is too less. Now I will recommend that you should have around, around, see, there is no thumb rule like that, but you should have good quality 2000 rows. Okay, 2000 rows of your data. If you are training a kind of question answer or any kind of instruction based or whatever, you should have at least 2000 plus to do that. Now let me just add here a few things. Now this is done. We have to convert this to a pandas data frame. You can see right now it says dataset dictionary, so we have to convert this into a data frame so we can use that later. So we need pandas here, so let's do that. So what I'm going to do is updated data equals, and then again inside a list I'm going to have a lot of key value pairs. So you have name, so the name here will go with item of name. You can see its name here, so item of name. And once you do that, item of name, you're going to have for symptoms as well. So let's do it for symptoms. And I only need name and symptoms. So that's why I'm going to only have two columns. I don't need code or treatments, because treatments, probably this model will not perform that good, because we're going to have maximum sequence length. I will explain that later. But this video will help you work with other similar videos, like for example Lamini, which is around 770 or some 700 million parameters. There's a model. Then you have Flan T5 by Google, which I recommend using it. So those kind of models you can use it for at least a bit longer sequence. I will explain that in a bit. Now you have your symptoms here, so let's do that. So symptoms, this is how you go symptoms, and in symptoms I write item and then here symptoms. So let's do that. Symptoms. Okay, now I'll come out of this key value pair for item in, and then it goes your data name, which is your data sample, and then you just write train. Okay, now you have, now let's have df. So df is now variable name of my data frame. Now pd.dataFrame updated data, and then I'm just going to do df.head 5, or if you just write head, by default gives you 5. Now if I look at this data frame, and I will tell you the use case that I am working on, which is very interesting by the way. Now you have your name and then you have symptoms. There can be a lot of use cases around it. I will tell you a couple of use cases. Now if you look at uh, uh, Turner syndrome or some syndrome, I don't know why I choose Turner syndrome, which is on row 3. If you look at short stature, gonadal dysgenesis, webbed neck, or something like that, right? Now the name and the symptoms. Now example, if you open this websites like Practo, okay, Practo or any other healthcare medical website or a medicine website, if you give the name, it starts giving you symptoms. So there is symptoms inside that page. On the page, if you look for a medicine or a disease name, it starts giving you different symptoms. So it has basically tags within it. Okay, now and this will help you on a lot of other things as well. Like if you are building a caching technique, a caching mechanism. If you are having a caching mechanism, you want to cache all of this in a database, you can start creating tags out of it, of all of the names, and you start saving it in a database. So the next time when people hit the system or hit the API, it should not go to a large language model or an API that you are paying it. You can just fetch it from a database. So that's one of the use case where you can create different tags for a disease, that will help you with the symptoms. That's one of the use cases you can do it. You can also do a reverse here. You can take symptoms and start giving the disease name, okay, using this. So it depends what kind of use cases you want to do. But for this, if you look at here, the symptoms, basically the symptoms are having one or two words, of course, that can. So basically one token means 4 characters. That's like how the standard is in natural language. There's nothing that it has been uh, like written somewhere that okay, you have to say one tokens mean 4 characters, but this is how we say it. Now for this video I'll keep word and token as same. That's what I'm thinking. If you look at here the symptoms are having, before, if you look at the comma, one of the symptoms have at least 1 or 2 words or max of 3 or 4 words, not more than that. That helps you with these smaller models. Okay, because if you have a longer sequence, the smaller models will not help because that context window is not there. Or if I don't talk about the context window, just imagine you cannot feed all of this to generate a new token. It does not accommodate all of those in that layers of the system, whatever you call it. Now that's why these are some of the limitations with the smaller models. But these are too small, by the way. When I say, when Microsoft says small language model, it's going to be more than 1 billion. Okay, but when I am saying small language model, it's around 300, 400 million. So please be clear on that, what you are doing with your terminologies when it comes to small language model. Now, these are some of the use cases that we're going to look at in this video. So let's see if we can achieve that. Now, DF is, so let's just extract the symptoms. So I'm just going to do is just extract, or let's just write it if we need that later. Just extract the symptoms, and for that, I hope you can see me, df symptoms, and in the df symptoms, and by the way, generative AI feature code completions and suggestions has been integrated within Colab, and that's why it's suggesting me that. Okay, df symptoms dot apply is correct. I'm going to use lambda here, so let me just do that. Apply, it was showing me lambda, lambda and x. So df lambda and then x and then x. And then what I'm going to do is, then you have that, if you look at that, you have a comma. Okay, so I'm going to have comma here, and inside comma, I'm going to have join x dot split, and the same thing. Perfect. I think there will be, okay, I this will not be here. Join x dot split. Perfect. Now this looks nice. Apply lambda x join dot x split. Let's see that. Okay, now, okay, this is fine. So we don't have to do anything else here. Now let's import this transformer library. So for that, what I'm going to do is I'm going to have from transformers, import GPT-2 tokenizer. So we need GPT-2 model and GPT-2 tokenizer. So GPT-2 tokenizer, and I'm gonna use the head of that model. You can see language model head model, LM head model. So let's do that. And I need torch thingy here. So import torch for CUDA and all. I'm gonna have torch dot neural networks to torch NN as NN because we need that for optimizers and a lot of other things. I'll show you now. Loss function, by the way, import torch dot optimizer, so that's optim. I'm gonna use optim here. So opt, where is that? Okay, optim as optim, and this looks good. And the next thing is we need to create a data set here that we can feed it to this model. So this is right, import data loader data set and then random split. So let's get a random split thingy here. This is wrong. Okay, now let's have the Nvidia GPU kind of thing. I don't know, because if you probably will not be using Colab, if you are on different systems, this will help. If torch dot CUDA is available, then let's bind the device to CUDA. So it uses CUDA torch dot device, and here I'm going to have CUDA here. So let's do that. CUDA else device equals torch dot device. If you are using Apple laptop or Apple silicon chip or whatever, you can then we have to use MPS. So let me also write that, because some of you might have this question, or you ask this question to me in your comment box, that I'm using Mac laptop and I'm using a Mac system. This has happened with C transformers and a lot of other libraries to use LLMs or inference LLM where you have metal and all. So you can use MPS there. Now, or let's put this in try cache, because okay, let me just do that. So else, and you put this in try to, not try cache, by the way, we are using Python. I'm not using Java, but except exception device torch, perfectly fine. Now this is okay. Okay, cool. Let's run this now. If you're on CPU, you can do that as well. This is fine. Now let's just do a device here. I hope it should show me CUDA and stuff. Now we are using a Colab here. That's why Colab Pro here. That's why it's showing you. We are on GPU. We are using T4. You don't need a high RAM, but I have that, so I'm just using it. Uh, Next is tokenizer. So tokenizer equals GPT-2 tokenizer. So let's get that from pre-train. I'm not going to use GPT-2 here. So let's use distill GPT-2 by Hugging Face. So let's copy, come here and just paste. So let me just paste. You can see I have pasted here. Now, also let's get model. So model GPT-2. Yeah, perfectly fine. And then just bind it to device. So it's you just your GPU. And you can see it's getting 353 or something MB, and it will just be done. Okay, you can see it's done now. We have our, and let me just print the model here. It gives you the model pipeline. Okay, you can show you some convolutional layer, etc., etc. You can see embedding, dropout, GPT-2 block layer, GPT-2 attention, C attention, projections, attention dropout, residual dropout, so on and so forth, right? Then you can go through and understand a bit in detail. Now that's a model pipeline, the way that they have used trained digital GPT-2. Now, uh, we need some models parameters. If you are familiar with deep learning earlier, if you have worked with CNN, ANN, RNNs of the world, you would have seen these parameters now, which are really fascinating to see nowadays, because we are working with this high level classes nowadays. We're not going this route now. uh, Batch size, So let's have a batch size. I have 400. Let's keep it 8, smaller batch size. I'm gonna have a batch size here. Okay, let me just see the data sets here once. So df describe, which is a method. So let me just print it out. You can see we have 400. Okay, there are some duplicates probably. Unique 392. We should have removed that, but it is fine. Let me add some cells, and you can see top one is psych. What is this? Psychotica, or I don't know how to pronunciate that, but it's something related to. I know it's something related to your nerves or the pain in leg or something, if I'm not wrong. Swelling, pain, dry mouth, whatever. Uh, Frequency and all of those things. Fine. Okay, let's now, this is the important part. We're going to have a data sets preparation here. So data set prep. Okay, in this data set, we're going to have a class. So let's create a class, and I'm going to call this language data set. Now I'm creating a class here because this will help you. And this piece of code is not mine, by the way. The dataset I have, of course, I have taken it from the internet, but this is really good because this will help you, at a lot of other places. And you can see it says df tokenizer max length. I think let's go with that. I'm not going to have max length here for now. Let's keep. So we have df and tokenizer. So self dot df tokenizer. Let me just remove that. I'll explain everything. So let me just remove that. And if you look at here, the first thing that we're going to do is we're going to have the labels that stores the column names of the data frame. So let's do that. So self dot labels, and in the labels I'm going to have df dot columns. That's the first thing. Now the next thing is self dot data, and in the data df we're going to use to dict. It should be a method. Yeah, to dict, and inside that I'm gonna give yes, correct, records. Fine. Now the next is tokenizer. So self dot tokenizer, which is correct tokenizer. Then let's have self dot, and here I'm gonna use a function here that's called fittest maximum length, and I will explain that, which is important for when you are dealing with the smaller LMs or the language model which are small. Let's first write it. Uh, Fittest max length, and it's a function where I'm going to pass my data frame. Okay, so let's pass it here. You have to explicitly define it here. Of course, we're going to write that function below. Now self dot fittest max length, and then of course this is right, self max length x. Now we are done with our first function here, guys. Now fittest max, I will explain fittest max length once I complete this piece of code. This is right. This is the length that returns the total number of samples, by the way, in the data set. Now this is done. Then what next is we need also a function of get item. So define correct self and the index, and this is not right, by the way. Okay, so let me just complete it. X equals self dot data, and then idx, I don't know, idx, and then self dot, excuse me, self dot labels, correct. And then same goes for y, self dot data idx. Let me just remove all this piece of code here. So now what we have done here, self dot data idx, self dot labels, and then we need the text. I don't need it. Yeah, it's too something text f, which is correct. Which is correct, and then the pipe, and then y, correct. Now this is my text, and I'm going to have tokens. So tokens equals self dot tokenizer, and I'm going to use an encode function here, not encode. Let's say use encode plus would be a function. Yes, encode plus going to pass text, return tensor, which is again a torch. Now it's not showing me so bad. Return tensor. So return tensors with torch, and then max length. And here I'm going to define a max length of 120 or something like that. max length 128, which is like pretty much recommended for this. And then I'm going to have a padding. So padding max length, and then I'm going to have truncation equals true. Yes, correct. And now just return the token. That's it. We'll deal with that. We'll deal with this later. Okay. Let me see once. And now I'm going to write fittest max length. You can see it suggests fittest max length. Now in the fittest max length, this is right. Now fittest max length basically computes the maximum sequence length needed for padding. Okay, this is why we are writing this function. It basically calculates the maximum length of the sequence in the data frame and find the smallest power of the two larger than the maximum length. Basically returns this computed length of the sequence that we have. Now, how should we do that? Let's have a variable max length. Max length equals, I'm going to use max, okay, which is a built-in function, which is correct. And then length, and again max, self key length. This looks good to me. Okay. Self labels key length, and then length max df key length return. But no, not return max length. X equals 2, and then this seems correct. While x max length, and then x equals x, and this is correct. Okay, return x. Hmm. Let's run this and see. Now let's cast the data frame. So what I'm going to do is again data sample. This is capital. Data sample equals, I'm going to have my language dataset class. I'm going to pass df and tokenizer. So let's do that. And now let's see data sample once. It would show me some object, etc. Yeah, correct. Now we need to create train and validation. So let's do that. So I'm going to have train size. So train size equals, and here I'm going to pass 80%, so 0.8, and length of data sample, and then validation size length data sample minus train size, and the same goes with train data. And so we have to use random split, by the way. So train data sets, and let's keep it data only. Train data and val data, and then random split, and then I'm passing the data sample, train size, and validation size. This looks good. Okay, now we have to make the iterator. So let's make the iterators now. So what I'm going to do is train loader. So let's do train loader equals data loader, where you're going to pass your, this is correct. I don't know what says suggested code means subject to data loader, train data, and batch size equals batch size, shuffles equals true. And I'm not going to do a shuffling in validation data. It doesn't make a lot of sense. So let's remove shuffle equals from validation set, just the valid data, and then batch size equals batch size. That's what I'm going to do. So let's do value blah blah blah. This looks good. Now let's set the number of epochs. So num epochs equals, let's keep 8 as num epochs. I'm gonna do it for 8 epochs, or probably we have 300 something. 8 will be too much. I will start overfitting after 4 or 5. I feel 5 should be. Let's keep 8. Let's keep 8 and we'll see. Mm, and after that, we have a batch size hopefully. So let me make it small batch size, and then model name. So let's uh, whew, uh, distill GPT-2, and then GPU equals. We have one GPU. I'm just gonna pass 0 here, so this looks good. Now the next is our data is ready, our params are ready. The next is to have our loss function and optimizer are ready. So for that, criterion, this is how we write, correct? Ah, this is criterion or whatever. Okay, and then nn dot. I'm gonna use cross entropy loss, which is basically used for classification. By the way, that basically classifies or assign the probability for the next target tokens, which is combination of softmax functions and the negative log likelihood loss, the combo of functions. So I'm going to use cross entropy loss. Let me first do here. I want to define a few things, and I'm going to do ignore. I'll show you ignore index, and inside that I'm going to tokenizer dot pad token id. This helps you uh, the computation of loss function. Basically it helps you there, ignores the padding tokens during the loss calculation. Basically it makes it a bit faster. Okay, also, and helps to prevent from affecting the loss computation. That's where it helps, and that's why we are using it. Now optimizer. Okay, optim dot adam. So I'm going to use adam here, adam optimizer. Basically it adapts the learning rate, by the way. That's it, model dot parameters, and 2e minus 5. Let's keep 5e minus 4. Criterion optimizer, and then end of stop token. So tokenizer dot pad token, and then it goes your tokenizer dot eos token. Okay, now this looks good. Cross entropy, ignore index tokenizer dot pad token id optimizer equals optim dot adam model dot parameters blah blah blah. Learning rate 5e minus 4. Tokenizer dot pad token. This is what I have in my notes. So this looks good. Okay. Okay. Now let me just add few more cells here. Okay, and here I'm gonna have uh, hmm. So let's do. Excuse me. Okay. Okay, my monitor got turned off. Tokenizer dot pad token, and now let's have our results in a data frame that helps you track better. So results equals pd dot data frame. We can create a data frame here. So data frame, and inside the data frame columns, let's define some columns. Okay, let's have epoch, and let me just do a lot of things here. Okay, transformer, and after transformer, let's have the batch size, and then have the GPU, and then have the training loss, and then have the validation loss. Let's do that. These are good practices to track everything. Epoch duration second. Let's do that here. What happens? It says, okay, I put somewhere dot. Okay, now results are there. Now for let's have a training loop. So let's write training loop, and inside that for epoch in range, and inside that I'm gonna have number of epochs. Of course, this is right. Number epochs, and inside number epochs, I'm gonna have my start time equals time dot time, which is correct. And this is how it can also help you calculate your carbon footprint. By the way, guys, that's a good idea. That's a good way of now tracking your uh, training. That helps you create a differentiator. You can start putting it in your pitch decks. Which number of epochs, by the way? Let me just do it here. Okay. Is it not number? Fine. Okay. Now model dot train, model dot train, and epoch training. Let's have an epoch training loss equals 0 to start with. Epoch training, and then train iterator. So let's have an iterator. Train iterator equals, I'm going to have tqdm, and inside this I'm going to have my train loader, and after that a description, correct, let's have a description. It was showing me something. Training epoch. Let me just do epoch plus 1, epoch plus 1, and then number epoch, excuse me, number epoch, number of epochs, and then you're going to have your batch size. Okay, so let's have your batch size, and inside that batch size I'm going to have uh, your batch size, which is again we made it small. Earlier it was like all caps. And then I have my transformer, which is your model name, by the way. That's a transformer we're gonna using. Transformer, and then that goes your model name thingy. So model name, and that's it. This looks good. Now after that, what I'm gonna have is uh, let me just hit in. Oh, okay. I don't know where this came from. Okay, I don't need it for now. Now optimizer.0grad. Okay, let's remove optimizer.0grad for now. Okay, or which let's keep it. Let's keep it this fine. Optimizer.0grad, and then yes, I'm gonna have an input. So inputs equals, and that will take your input ID is to not divide. That's squeeze first to one. So squeeze. Okay, yes, correct. Squeeze dot to device, and then uh, your outputs. So outputs equals, and in the outputs, what I'm going to have is model dot, not model dot, outputs equals, or we're missing something. Inputs, output will follow later. The next thing is the targets. Correct. It's showing me right. Targets equals, just clone the input. That's it. We can just clone. Correct. Inputs dot clone. That's it. Now our output, then we go model, and inside that model I'm going to have input IDEs. So input IDEs equals inputs, and then my labels equals targets. This is my labels, targets. This looks good now. Then loss equals output loss, which is correct. Loss dot backward optimizer dot step, and then up till this we are good. Optimizer dot step, and then what I'm going to do is have a set postfix. Yes, it was showing right. So train iterator dot set underscore postfix, and inside that let's have your training loss, and then it goes loss dot item, which is right. Now train iterator dot set fix, then epoch training loss, which is right. Epoch training loss, and then epoch training loss, and then average epoch training loss, which is epoch training loss length of, hmm, why should it be train loader? This should be train iterator, because we have train iterator dot set postfix. Correct. Train iterator. Now this gives you average. Now we go into the validation. So we are done with our training step. Now in validation, model dot eval. Yes, correct. Epoch validation loss. So epoch validation loss. Let me just do epoch validation loss equals 0. And after we're gonna have total loss, and inside total loss we're gonna have 0 to start with, and then valid iterator. Okay, so that's a validation iterator, and in valid iterator I'm gonna have tqdm, and then have val loader, where we are describing validation epoch, epoch plus 1, and number epochs. We don't need all of this batch and transformer for validation. Again, it's a repetition of same. Now this looks okay. uh, Basically you can ignore this if you don't want this verbose. Of course you can ignore this part of code. This will help you track each and everything. You'll be able to understand how it's happening. Now with torch dot no grad. Okay, so let's just do that. No gradient, by the way. With torch dot no gradient, and inside this for batch in valid iterator, and inside this I'm gonna have my inputs, uh, batch input IDs dot squeeze one to device, and then targets inputs columns, then outputs again same thing, outputs equals model input IDs equals inputs, labels equals targets, and then you have loss equals outputs dot loss, and then excuse me, I'm going to have total loss here. So total loss, now total loss becomes, no, not becomes, okay, same thing. So it's better to write the follow the same way we have followed above. Total loss equals just loss, total loss. Now valid iterator dot set postfix validation loss dot item. This is right. Now epoch validation loss e or the same thing, right? Let's keep it same, plus equals loss dot item, which is correct. Now we are okay with this, guys. Okay, and then average epoch validation loss equals epoch validation loss by length of validation iterator. Okay, yeah. Now we're gonna save that. So let's end time now. So end time, and end time equals, I'm gonna have time dot time, or that will be just a second. Well, order. Fine. Now end time. So end time equals time dot time, and then your epoch duration second equals, and then it goes end time minus start time. That's basically calculates the duration in seconds. Okay, epoch. Now we have a new row in our data frame. So in new row, we can have all of those things. Okay, from transformer. So transformer, basically it's a model name. So let's do model name. Uh, phew. By the way, let me just do one thing here, and let's start writing here. That basically looks good. Transformer equals model underscore name, and then you have your batch size, GPU, and then let me just also put epoch here because we have epoch. So epoch equal epoch 1, epoch plus 1, and then you have training loss, which is average epoch training loss, and then you have your validation loss, which is average epoch validation loss, and then you have your epoch duration second, which is basically your epoch duration second. Okay, now you complete, and then uh, okay, now your new let's have the results dot, I'm gonna use lock, so result length results new row, this is right. New row, this is correct. What else? Let's have a print thingy here. So print f epoch, excuse me, epoch and epoch, and then here it should be, of course, epoch plus 1. This is nice. And validation loss. Why I'm writing like this in here? Now validation loss equals, or not equals, basically it's a key value pair total, excuse me, total loss divided by length of the val loader. Okay, now let's run this, guys, and see what we are getting here. It will take a bit of time, but now let's run and see that. Generalizing well. If you look at for two epochs, it has generalized well. Now I told you, right, because we have around 300 training and then 80, 320 by the way, and then 80 of them. And now you can see it starts overfitting after three epochs. So with that data, you should not do it for eight epochs because now you can see it start overfitting. So it's now memorizing your data. It's basically not generalizing, now it's memorizing a bit. But now it's we'll see that training loss. Training loss has gone down, of course, because now it has you have eight epochs have been going into for loops and finding the patterns, learning it. But by the way, that's not a good way. So eight epochs we ran and have a validation loss of around 0.9. We started with 0.7, so it starts overfitting after fourth or something. So you should train it for at least four or five for this data, at least if you want to use this data. Now, what I'm gonna have is let's try it out. Okay, so let's see input string equals, and I'm gonna have something called, let's do the same kidney failure I told you in the beginning. Okay, kidney failure. Let's do that, and then first we need the input IDs. So input IDs equals, I'm gonna encode with tokenizer. That's what we're gonna do, right? Tokenizer dot encode, and I'm gonna pass my input string and return tensor and that to device. Let's do that. And if you print input IDs, this is how it looks like, by the way, if you want to track it down. You can see here, it's the IDs of your tokens, okay, that you have encoded. If you just do the decode, it will give you the text back. Okay, device CUDA, you can see it over here. Now for that, what I'm going to do is output equals, and then here model.generate. This is where we're going to use model.generate. It's going to generate some tokens, guys. Model.generate. Let's have our input IDs, max length. Let's keep not 128. Let's keep 20 for now. We'll just test it out, and then I don't need that. These are all inference params. So for that, I'm going to have number of return sequence, and we'll keep a very small. So uh, number return. Why it's not suggesting me? It's so bad. Number of return sequences equals one. What the hell? Number of return sequences one, and then do samples true. Top k 50, no, too much. 8 top p, which is correct. Temperature, let's keep 0.5, not being too creative, and then have a penalty as well. So let's have a repetition penalty if it gives you. Let's keep it too high, 1.2. Okay, fine. And then uh, let's remove it for now. We can look at this later. Model.generate input IDs, max length 20, number return sequences 1, do sample true, top k 8. Let's try it out. It says, oh, we should have used that, the EOS token and PAT, but it's fine. Let's now decoded output. We have to decode that. So decoded output. Now let me just show you here once. I'll just add a cell. I'll say output, and you can see you got some tensors. Now you have to decode that tensors to you get the text back. You encoded, you got some IDs. Now you have some IDs. You have to decode back. Now decoded output equals tokenizer dot decode. Let's use the decode thingy here, and I'm gonna pass output skip special tokens to, which is correct. And you can see we got what we wanted to have. You can see severe sore throat, difficulty swallowing, nausea or vomiting, which is wrong, by the way. But we are able to generate the tokens. Okay, now as the model has started overfitting, maybe you make it less epoch, or see how we can tweak the hyperparameters and train it again. But let's try it out with something else. Now kidney failure was nice. What else we can think of? I don't know what else we have, but let's try it out with something like, you know, uh, pneumonia. Do we spell like this? itching and visual presence of pus or urine in the infected area. This is again not the right response, but it's able to generate the response. Okay, this is important, but again wrong. So it doesn't make sense if it's generating wrong responses. So we have to tweak the hyperparameter, but we'll keep on trying. Let's see if it's able to get it from even trained data. We had something called Turner syndromes or something. Okay, let's try it out. So it's able to memorize it. So it's now the model has memorized your data and it's able to generate tokens for that particular uh, training set. Now, if you have your larger training set, and maybe with this model itself, of course, after tweaking the hyperparameter, it might performs even better. But this is the right response. Let's try it out something else. But let me see what kind of data it has. Okay, it has. Let me try something with depression. If it has something for depression or something like that. Correct. So now you see the responses are coming because this has seen the model has seen in the training steps, and that's why it's generating that. But you can see performing good. Let me first save the model. Okay. You can just do torch.save by the way, and torch.save. You can also push it to Hugging Face repository if you want to create. Let's call it a small. Let's call it. I don't know what to call. A small mid lm. Or let's call small digis lm or something like that. Okay, and then okay, and then you save that with pt. So I'm saving that small digis lm, or I should have saved that. You can see it will probably will be saving here. You can see it has saved here, but let me save in my drive. So torch.save model and uh, drive, because I'm using Google Colab, so I can save it on my Google Drive, and I'll show you that how I'm gonna use this in my upcoming video, the model. I'm gonna create an app to create tags out of it, and that tags can be used in caching or those kind of mechanisms. Okay, small digits lm, and let's save that. It says parent directory, blah blah blah, drive. Oh, I didn't mount it. Okay, I have to mount this. So let's mount my drive. Meanwhile, I will open my drive here quickly. So let me just open my drive. But that was a very interesting exercise, guys. I hope you learned something in this video, how you can take a model and generate some text tokens for a specific use case, which is very small in the size. And you can see we can generate up to 128, by the way, the max length that here. Uh, Let me just see. Okay, it has mounted probably. Perfect. So small digits lm, it has been saved, and you can see it has been saved here as well. Now I'll just do a refresh. I'll come back. Its name is small digits lm. Okay, let me just do a small digits lm and search, and you can see that I have my model here. Let me just download the model. It's downloading the model. It says 318 MB. So now on the 300 around size, 300 MB size, you have a language model that can execute a specific task which is very domain specific, where you have your data. You are leveraging a model to create a new model that can execute those kind of tasks, or you can implement the use cases on top of it, and that's what we achieved here. And you can see it's performing. I'll not say it's the best model, of course not, not even I'll say that good, but this can be this can become better after tweaking a bit and taking a slightly different approach with the hyperparameters as well, and of course improving the data, which is not that good at this moment. But yeah, one of the use case. Let me try it out something else here, like mental disorder. Now if you have mental disorder or something, let's see what it gives. No, it's something related to teeth. Okay, so it has got this wrong. Yeah, but fine, because the model has overfitted, and you should not deploy this model in production. But the whole agenda of this video was to give you a way that how you can take a model on a smaller data set, a small model, and create something that helps you generate some tokens. That's for the agenda. Now let's see once it downloads the model. You can see it has downloaded the model around 319 MB. Now you can use this model, of course, the better version of it in some kind of application to perform a specific task. Right now you can use this in medical, healthcare, financial services. For example, based on the age of person, you can just start recommending different plans, insurance plans or products, etc., right, with a very small model. Yeah, that's also the video. I think this is what I wanted to achieve in this video, guys, and the code will be available on my GitHub repository. And uh, please go and find the notebook there and improve it further. Let me know what do you think of it, and if you have any thought and feedbacks, please let me know in the comment box. And if you haven't subscribed the channel yet, please do subscribe the channel, like the video if you like the content I'm creating, and if this content as well, and share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.